Come Chapter 4. Okay, your information gets more and more now. Let me ask you. Okay, let me ask you this very simple thing from chapter 1. Okay, I don't need you to activate a lot of fantastic theory. If I give you a vector 1, 1, 1, what does it represent? I just say 1, 1, 1. What does it represent? Can it represent a point? Relative to origin, the position of 1, 1, 1 is somewhere relative to origin. What else can 1, 1, 1 represent? Can it represent a direction? A direction of 1, 1, 1. Can? So that's what we went through at the very onset in chapter 1. So without any further information, if I just throw you a column vector 1, 1, 1, it can represent either a point or it can represent a direction. Okay? So if I reference it, okay, let's say this is your x and y axis. So 1, 1, 1 is down here. Okay? So it can mean a point, referencing from origin. Or 1, 1, 1 can mean a direction, this direction. Agree? So this direction is 1, 1, 1. This direction is 1, 1, 1. This direction is 1, 1, 1. I can move around as long as I'm shooting up towards this direction. It is 1, 1, 1. Can you get this theory? Okay, good. So now I want to extend this theory a little bit now. Secondary school, you learn your equation of a line. It looks like y equals to mx plus c. Familiar? M is the gradient, right? C is your so-called y-intercept. Agree? So I'm going to map this knowledge over to your vectors. If I want to stipulate an equation of a line, a specific line, let's say I really want this line. Okay? What I will need is two pieces of information. I need a point and I need a direction. Okay, why do I say I need a point? Because 1, 1, 1 can represent this direction, right? Can represent like that. Can represent like that. I can move around. This is all still 1, 1, 1. But what if I say I want the equation of this line? This line only. I don't allow it to shift. I want the equation of this line. I'll need a point for it to start, and then I'll need a direction for it to move. Do you agree? So let's say I want this direction, right? I want it to start from this point instead. It must start from this point and go this direction. I want it to start from here instead. It must go this direction. Can you understand what I'm talking about? So to describe a line properly, a specific line properly, I'll need a point. I'll need a direction. Agree? So next thing. How do I describe them, or how do I put them into your picture here is that to describe a line, your general equation will look, I fast forward like this. R equals to A plus lambda U. Okay? R equals to A plus lambda U, where A is a point on the line and U is the direction by which the line is moving. Okay? So all the theory in front, let's skip. I use common sense and I use practical to help you. So if I say that this point, okay, the head of the projector is 201. Okay? Let's say this point is 201. Okay? Then I want it to go in the direction of 111. I want it to go this way. So what I will do is plus lambda 111. This will represent your equation of this specific line I'm talking about. Can you follow? So what if I say I want to change? I don't want this point 201. I want a line that is equally parallel, but I want it to start from here. So let's say this point is negative 731. What is the equation of this line now? So it's negative 731 plus lambda 111. Make sense? Can accept? This is how we form the equation of a line. So repeat again. To get the equation of a line, I need one point, I need one direction. So what's the word? Yeah, let's confuse you even more. What is that lambda? What is this lambda thing? It's just any constant. Okay, so let's bring it down to practical again. I say 1, 1, 1, right? This direction. Can I use 2, 2, 2? Can I use minus 1, minus 1, minus 1? 20, 20, 20? They're all carried out, right? So what does the lambda do? You subsume all these possibilities, right? Can you understand the purpose of the lambda now? Okay, so what we usually put here, beside the lambda, the direction, is usually what we want to use is the lowest form, so that it is easy for calculation. Of course, you can tell me, I want to use 100, 100, 100. I cannot stop you on it. It's just that you are creating hell for yourself. Clear? Can you understand? So, let me ask you now, 201 plus lambda minus 1 minus 1 minus 1. 1, 2, 3. Which of the lines are the same? Which lines are the same lines? 1 and 3, right? Is 2 the same as line 1? What is the characteristics between these two lines? They are parallel, but they start from different points. Okay? So in a 3D space, what does it represent? So what it means is that one line could be like that. The other line could be somewhere like that. Agree? Then, must the line go this direction? Or must the line, can the line go the other direction? How I know? Which direction? Actually, I also don't know. It's just a sketch. But what is most important is, line is never ending. It's a line. You shoot on and on and on. Upwards, you shoot on and on downwards. Accept? Can I accept? Anyone not clear as far as the theory behind the line is concerned? Can? Okay. One step further now. You more or less understood the effect of lambda. So what if I say lambda is equals to 1? What will you get? Yeah, let's throw everything. Let's just focus on equation number 1. If lambda is equal to 1, what do you have? You get 201 plus 111, right? So actually you get 312, right? So when lambda is equals to 1, you get r equals to 312. What does 312 mean? Okay, let's think like that. Y equals to 3x plus 1. When I substitute x equals to 1, what do you get? Y equals to 4. What's so special about 4? Or what is this 1, 4? It's a point on this line, right? When I say x is equals to 1, y equals to 4, what it means is that 1, 4 is a point on this line. Can you follow? So what if I say lambda is equal to 1? What's so special about this 312? 312 is a point on line 1. Make sense? Can I accept? Anyone don't know what the hell is happening? Let's try again. What happens when lambda is minus 1? What will you get? You get 1, 0, 0, right? So 1, 0, 0 is a point on my line 1. Can I accept? Can I accept? Anyone still not sure what the hell is happening? Still don't know? Understand the equation of a line? Can? Okay. Don't think too much here. Just look at y equals to 3x plus 1. Can? Just look at y equals to 3x plus 1. When I substitute x equals to 1 into 3x plus 1, what do I have? Y equals to 4. So what is this 1, 4? A point on your line, y equals 3x plus 1, right? So similarly, think along the same train of thoughts. If I say that lambda is equals to 1, I will produce 312. Substitute lambda equals to 1 into the first equation. Simplify the whole expression here. 2 plus 1 becomes 3. 0 plus 1 becomes 1. 1 plus 1 becomes 2. I get 312. 312 will be a point on my first line. Can? Anyone still not sure? Okay, So usually this is what I like to do. I don't like you to read all the stupid lecture notes. Cannot understand one. You understand this way is easier. Can? Okay, so here comes to your proper presentation. Okay, this is how we usually represent the equation of a line. As I said, a plus lambda u, where a is a point on the line, u is the direction that the line is progressing. Okay, most of the time students just give me this, but I want your batch to be more specific. Can you add in for me, comma, lambda is an element of a real number. This way you'll remember it better. So how many values can lambda take? Infinite number of values, right? So with every specific value that lambda I throw in, I will be able to get a point on a line, on this same line. So lambda can take infinite value when it comes to an equation of a line. But when I'm talking about a specific point on this line, it will refer to a specific lambda value. Can understand? Anyone not clear? So reminder again, you have learned your complex number. Lambda must be real, cannot be complex. Lambda must be real. It should not be confined to just an integer. So lambda can be 1, can be 1.231, can be 7.21187, whatever you want. Okay, everything is applicable. Every lambda that you pump inside there will produce a point on the line. Okay? Okay, so this is roughly what you have. Okay, let's put it in all these. Okay, let's look at this example. It's easier for everything to sink in. Okay, your job now, find for me a vector equation of the line through this point 101 and is parallel to 1, -2, 3. Okay, so the moment a question like that comes up, what must trigger in your brain is, how does the equation of a line look like? So straight away you must tell me, the line must have a point, the line must have a direction. So where is the point that I'm referring to? Follow the question. We say the line passes through 101. Write down 101. Okay? Equals to lambda, the direction they are referring to. Can? Presentation wise, let me remind you again, it is absolutely necessary to have the arc. Okay, because many students in the exam will just tell me equation of the line equals. Cannot. I need equation of the line represents R equals to whatever. The R is necessary. So far so good? So far so good? Last bit. Okay, this is when you must think a bit now. Again, now instead of giving you all the information, I just give you 2 points. I have a vector, I want you to find a vector equation of the line passing through A and B. So I need you to do a sketch first. Okay, can you do a sketch? Okay, the question don't have sketch. So where is AB? Just draw. Okay, a sketch is just a sketch. AB down here. So I want the equation of the line AB. Okay. So wait, don't copy yet. I want you to think through first. To describe a line, your equation look like that. A plus lambda B. So I'll need a point, right? And I need a direction. Let's settle the point first. Who is the point? A or B? Or anything? Must the point be A? Can I use B? Yes. Okay. So the point here can refer to either point A or point B. Your choice. Okay, I just need a point. Second thing, I need a direction. The line passed through AB. Where is the line going? In which direction? AB or BA? Can it be BA? Why cannot? What's the purpose of the lambda? The lambda can subsume all possibilities, right? So back to the same question. What's the direction? AB or BA? Or doesn't matter? Doesn't matter. You understand? Okay, so it's more important to get all these things internalized in your brain straight away. So what I'm doing here, AB or BA? Okay, the solution that you're trying to find. A vector that is parallel to the line. I do a 7, 2 minus 4 minus 6 minus 1, 5. This one is AB or BA? Chapter 1 skill. This is actually AB. I'm finding AB here. Okay, but if you don't want AB, you can use BA. It's your choice. Because they are the same. Can? So how does the equation of the line look like? Try. Put it down on your own. A plus lambda B. Which one you want to use? It is your choice. In your lecture notes, I just put 7, 2 minus 4 plus lambda 1, 3 minus 9. It is absolutely possible. If you want to change it to something else, like what you see on the right hand column. Okay, some people want to do something different. It is your choice. Everything is still acceptable. Questions so far? Can Okay, come. Okay, this part, directional cosine, I'm not sure how many of you all can remember. Okay, what you all learned in your chapter 1 and your chapter 2 is your concept on directional cosine, and I told you don't bother too much on it because no questions can be set. Okay, so same thing, let's do some recall. Okay, I want you to find the directional cosine. Let's use practical again. Let's use the OHP head again. Okay, directional cosine of this point, of this vector. What is your directional cosine? The cosine of the angle that it makes with the x-axis, the y-axis, and the z-axis. Okay, that's your direction cosine of a vector. What is the directional cosine of a line now? So it is the same. It's the angle that the line makes with the x-axis, the y-axis, and the z-axis. Nothing fantastic, just that I want to ask you now. I told you line is never ending, right? The line is never ending. It just shoots up, it just shoots down. What is the angle that this line makes with the so-called x-axis? So if I were just to do a sketch for you, okay, let's say this is the line. Okay, so the sketch. This is the x-axis, right? Let's say this is the x-axis. What's the angle that your line makes with the x-axis? Is it this angle or is it this angle? Which one? It can be the acute angle or it can be the obtuse angle, right? Agree? Because x-axis, angle with the x-axis is either acute or obtuse. So what it means is that when it comes to directional cosine, I can accept either the acute angle or the obtuse angle. And what does it mean? You can accept the plus minus of your version of the directional cosine. Simple as that. That's all you need to remember. Okay? Directional cosine of a line is the plus minus version of the directional cosine of a vector. Okay? I will stop here today, no? So